Okay, so in this video, we're going to talk about still writing the equation of a line, but these are special cases. And by special cases, we're talking about when the line is not diagonal, when it's either a vertical line or a horizontal line. So vertical or horizontal. Alrighty, so in this instance, we're always talking about M and B, but this time they've told us M is undefined. So when M is undefined, that means the line is up and down. So you can use that sort of as a way to remember up and down, which we know that means it's vertical. So I probably will want to picture this. So let's just visualize it. So if I think about if I'm going to graph this, and I know that it's a vertical line because undefined is up and down, it's vertical, but I have to pass through this point, 7, -2. So let's just draw that. 1, 2, 3, 4, 5, 6, 7. Okay, so 7, -2. But I'm a vertical line through that point. So I know vertical is up and down. So I'm going to go with a vertical line up and down. Now, what I notice is that my vertical line only crosses the x-axis. So a vertical line, my line only crosses the x-axis. What that means is my equation will only have x. I don't use my template this time around because it's a special case. So because it's a vertical line, it's up and down, this line is only crossing the x-axis. And I can see that it's crossing the x-axis at 7. 1, 2, 3, 4, 5, 6, 7. That means every x value is a 7. So if I were to draw all those dots, every x value would be 7. So my line only crosses the x-axis, so the equation will only have x. X equals 7. And that's the equation for that special case. Now that, I know you cannot put it in the graphing calculator. Let's try to put it in Desmos and see what happens. So if I put it in Desmos, let's x out of that, x equals 7. Yes, I can see it here. See that vertical line? X equals 7. So undefined slope is up and down. A vertical line, it only crosses x, so you can only have x. The letters in the equation let you know which axis you can cross. So right here, another special case. M is 0. That means my slope is 0, a perfectly flat line. So again, in this case, it's easiest to visualize it. So I'm going to draw our x and y axis. But they've told me my slope is 0. But I've got to go through 4, -6. So let's graph that. So we'll extend that a little further. So 4, -6. And I have a slope of 0. So a slope of 0 is a flat line. All right. So if I draw a flat line, through that point, it looks like that. So I can tell I'm only crossing the y-axis. See, I'm only crossing y. I don't even come close to x. So what I notice is all of those y values are down here at -6. So my line only crosses y, or I should say the y-axis. So my equation will only have y. So y equals, and I was down here at -6. Okay, now this one you can check in the calculator because we have that button y equals. So if I go back, I'm going to clear that out. Y equals -6. And if I graph it, there you go. There's my line, flat line, 0 slope, right there. We said if our slope is 0, we have a flat line. So we can check it in the calculator. Now what's neat is when you look at the table, if you second table it, all of your y values are -6 because we had a flat line. And you can see that all the y values are -6. Same thing in Desmos. I can check it in Desmos. So I'm going to erase that x equals, put y equals -6. And there you go. There's that perfectly flat line. If I generate a table, go to the gear, select table, you can see all your y values are -6. So those are some special cases. It's when you have a vertical line or when you have a horizontal line.